Welcome to Math 1111 Pre-Calculus, and this is Professor Bright. In this class, we are going to be using the flipped classroom to teach. So what that is going to entail is one of the instructors is going to be making a series of videos for each class, and we need you to watch them. There will be a quiz on them, and literally the quiz is like word for word out of our videos. So please take notes, pause the videos, rewatch the videos as needed, and come to class with your notes because you can use those notes on a quiz. So it is beneficial for you to have paper notes. We do not accept electronic notes. So just make sure to take paper notes for each class period and watch the videos in advance. Okay, so this first section is going to be on functions and relations, and so if you took college algebra or if you had some algebra experience, you might remember what a function is, and that's really what our goal is. We want to talk about relations and functions, how they compare and contrast, and then talk about the representations of a function. And so here you can see our overall learning target, and this is the one thing that if we had to write a test question on, that is the one question that we are going to write. So is a function, or is a relation a function? And then also, how do you represent a function? That's our goal. And then you can see the learning steps. So these are the different pieces that we need to be able to do to get to our target. So compare and contrast, represent a function algebraically, graphically, tabularly, descriptively, and then talk about function properties. Okay, and so then below this you'll see that I just wrote out kind of the videos. So there's going to be 5 videos for this section, and then we're just going to finish here with a little idea. So this course is called Pre-Calculus with Physical Concepts, right? So we are going to try to introduce a model or a physical context in which we're going to work for each of these sections. So you can expect the very first video is likely going to be some sort of application that we don't have the answer to yet, and then by the end we're going to come back to it, or at least come back to the idea of it, and go forward with that, and use the tools that we developed in the section to respond to it in some way, shape, or form. Okay, so the first question we want to introduce is, how do we talk about population growth? So I copied some data from the World Bank about the U.S.'s population from 1960, and you can see I only did from 1960 to 1978, so what, 18, 19 years. But in the course of those years, we went from about 18 million or 180 million, sorry, up to 222 million. So 40 million people ish. Was the change in our population. But then the question is, so if we only have this snippet of data, it is the year 2020 now, how do we go from there? So can we create some sort of projection as far as what the population would be based on this data, and then also how accurate is that projection? And that idea is really where a model comes into play. And when we use the language of model, you can imagine like you made a model toy or model, building, model car when you were younger, maybe, perhaps, or you made some sort of device, and that was just really a image of what it could look like. And so in mathematics, same sort of idea, we're just going to mathematize it, and we call a model a set of variables, equations, variables and equations that attempt to describe a pattern or relationship among the variables. Okay, so it's just an idea of here are the variables, here's an equation that we're working with. How do these things relate? Okay, and so then the ultimate question that we want to be able to answer, at least in this context, is how do we make a model for population, and I'm going to say US is implied here, And also, you could also look at population, or you could just look at population growth. Okay, and forecasters love to try and answer this question because really we're trying to look at what our environment's going to look like in 2040, in 2100. Okay, something like that, and that's where mathematical models can help. So this is the end of the first video. Again, just overviewing everything, talking about what a model is, and then kind of setting this context of, okay, we're talking about population growth, and we have this data. How do we use mathematics to help inform this model?